Hello, and welcome to this video where we will be continuing our journey into gates, in quantum gates, where we have already seen the X gate and the Hadamard gate, and we will look into another one which is very useful for the foundation components, and that is Pauli Z gate. Now it is important to understand that the X gate and the Hadamard gate that we have seen before are kind of gates which help change the probability distribution and in terms therefore magnitude. However, Pauli Z gate has a bit of a different nuance to it, and they actually introduce what you call as a difference in the phase. So they are basically changing the phase of the state. How should we interpret this? Let's look on. A Pauli Z gate is represented by the matrix as you can see on the screen. So 1, 0, 0, minus 1. And what it does, as I said before, is that it introduces phase change. So let's look at an example. If you apply the Pauli Z gate to state 0, you can easily prove that you will end up getting a state 0 as output. If you apply the Pauli Z gate on the state 1, you will end up getting minus 1 state. Now, there is nothing called as minus 1 state. The minus sign here represents that the phase has changed from input to the output. So therefore, the probability distribution for the states will still remain the same, but the phase difference is now being introduced by Pauli Z gate. And you can mathematically prove this if you just apply the linear algebra, the matrix and vector multiplication. You will see the output that you get when you apply the Pauli Z gate on state 0 and 1. So it's not very hard to prove. Therefore, what we have seen before in terms of the X gate and the H gate, they are normally called as the state change gates, because what they do is that they change the probability distribution of the component state, and then you get an output when these gates are applied on a particular input. They are also called as a bit change gates because the way, for example, the state bits are changing from 0 to 1 and 1 to 0 when you apply the X gate. So these are some of the different names. And on the contrary, Z gate, as said before, is a phase change gate, which does not change the probability distribution directly. So the phase, of course, has changed. The direction to which an state is referring to has changed because of the phase change, but the distribution or the component of the state or the contributing component of the state has not changed. Now, this is a very important distinction to have, because when you combine these gates in actual circuit, you need to know the meaning and the purpose of these gates, because if your intention is not to change the probability distribution but only to the phase, for example reversing the magnitude and things like that, you know that you have to use a Pauli Z gate and not, for example, Hadamard gate. So what I'll do is that I'll stop here, since we have covered all the basic gates that is required to build our circuit, our complex circuit. I hope you enjoyed this video, and I hope to see you in the next one. Thank you very much.